You all able to see my screen, students?
Yes, sir.
Yes, very nice. I guess we covered a few of these questions, right? I think till 5 we have completed in the class, correct?
Yes, sir.
Yes. 6 to 10 we will do it now. Okay, students. So I have discussed about cube roots of unity, right? So what do you understand? What are the results? You remember? 1 omega square are the cube roots of unity, which means are the roots of the equation x cube is equal to 1, correct? We had learned two properties, right, students? What were the two properties? Omega cube equals 1 is one of the properties. And the second property is 1 plus omega square is equal to 0. And in the class, I had also proved each one of these. Right, students? Omega is the root, minus 1 plus root 3I by 2. Omega square is the root, minus 1 minus root 3I by 2. These were the discussions on cube roots of unity. Is it clear, students? Are you able to recall all these? Am I audible?
Yes, sir.
Yes. Okay. Now, let's solve this question with this information. Right? Most of these questions you can solve just using these identities. Right? So let's look into this. Let's look at what is 1 minus omega plus omega squared. Okay. So can I write it as 1 plus omega square minus omega? I'm just clubbing these two terms together, correct? So 1 plus omega square minus omega. So can you tell me what is 1 plus omega square from this? If I retain 1 plus omega square on one side, what goes to the other side?
Omega, sir.
Omega goes to the other side. So it will become what? 1 plus omega square will be nothing but 1 plus omega square is 0. So if I retain 1 and omega square on this side, just shift this omega to the other side, what will I get, ma?
Minus omega.
Exactly. So in place of 1 plus omega square, I can substitute what?
Minus omega.
And already I have a minus omega. So what do I get? Yes? Minus omega is what? Minus 2 omega, correct? What is minus x? Minus x. Minus 2x. Clear?
Yes, sir.
Now let's look into the other one. What is the other one? 1 plus omega minus omega square. Now, same equation. I'm retaining 1 plus omega here. Taking omega square to the other side, what would I get?
Minus omega.
Exactly. So in place of 1 plus omega, I can write Come on, tell me, students. In place of 1 plus omega, I can write.
Minus omega square.
Yes, very good. Yes. So minus omega square becomes
2 omega square.
yeah, minus 2 omega square. Very good.
Excuse me, sir.
Yes.
Sir, it's actually the 1 plus omega minus omega square, the whole 5, sir.
That's correct. That's correct. That's correct. Now I'm just checking, what is this part alone. You are right, Jerome. We are going to come to that.
Okay, sir.
Okay, sure. Very good. So now we will deal with that, what you said. So it is not actually 1 minus omega plus omega square, but rather raised to power 5. Correct, Jerome?
Yes, sir.
So this whole thing power 5 or this whole thing power 5. Okay now?
Okay, sir.
Yes. So what is minus 2 power 5? Correct. Minus 2 power 5 is minus 32. Right, Jerome?
Yes, sir.
Multiplied by omega power 5. Correct. Is it clear till here?
Yes, sir.
Yeah. Now, omega power 5, how can I write? Omega cube into omega square, correct? What is omega cube?
1, sir.
Yes. So 1 omega cube becomes 1. Therefore, what does this become? Minus 32 omega square. Is it clear, students?
Yes, sir.
Yes. Now, similarly, this is not 1 plus omega minus omega square, but power 5. Is it okay now?
Yes, sir.
Yes, okay. So now tell me, what is minus 2 power 5?
32.
Yes, minus 2 whole power 5 is minus 32. Omega square power 5. What is omega square power 5? Yes or no? Omega square power 5. 2 into 5, right? Clear?
Yes, sir.
Yes, okay. Now, how can I write omega power 10, students? Can I write it as omega power 9 into omega? Power 10. I can write it as omega power 9 into omega power 1. Yes?
Yes, sir.
Right. So that becomes minus 32 into. Can you tell me what is omega power 9?
Omega 3 the whole cube.
Exactly. So do you now recognize why did I split this as omega power 9? Nine is a multiple of 3 and omega power 3 is 1, correct? So what does this become? What is omega cube? Come on, what is omega cube?
1, sir.
1. So 1 cube is 1. So what are we left with? Minus 32. this entire thing becomes 1, right? So minus 32 into 1 into omega. So that becomes minus 32 omega. Is it clear? Can I have a response, students?
Yes, sir.
Yes. So what is this going to be equal to? This part is nothing but, come on, tell me, what did we get?
Minus 32 omega square.
Yes. And what is this part? The second part.
Minus 32 omega.
Minus 32 omega. Exactly. Now, from both these, I can take minus 32 outside. What would I be getting? What is common in the first term? Omega square. Second term, what is common? Omega. So I have minus 32 into omega square plus omega. Guys, tell me, what is it? We know that 1 plus omega square is what? 0. So what will be omega plus omega square?
Minus 1.
Exactly. So it will be nothing but minus. Therefore, this will be minus 32 into minus 1. So what would we get? 32. So what is the right answer, students?
32.
32. Exactly. Please take it down, students. If you have any doubts, let me know.
1 and 1 plus omega square is equal to 0. So we take the first
First part.
so we take the first part. So 1 minus omega plus omega square raised to 5. So instead of omegas,
Tell me, Jer. I am combining 1 and omega square first. 1 plus omega square minus omega. I am writing it like that.
yes, sir.
Go ahead.
So instead of 1 plus omega square, we replace it by minus omega. So minus omega raised to 5. So it becomes minus 2 omega raised to 5. So minus 2 raised to 5 is minus 32 omega raised to 5. So we separate omega 5 into omega cube into omega square. So we'll get minus 32 omega square.
Because omega cube is?
Because omega cube is 1, sir.
Very good. So the first part of this becomes minus 32 omega square. Very good explanation, Jerome. Now next part, can you explain?
Yes, sir. So next part, 1 plus omega minus omega square the whole 5. So now we take 1 plus omega and replace it by minus omega square. From the equation 1 plus omega square is equal to 0. And minus omega square the whole raised to 5. So we add both, so we get minus 2 omega square whole raised to 5. So we multiply 5 into minus 2 raised to 5 and omega square into 5. So get minus 32 omega raised to 10. So we separate the omega 10 into like omega 9 into omega raised to 1. So as
Jerome, I'll interrupt you at this point. You have been doing great.
Yes.
Jerome, what is the logic behind splitting it as omega power 9 and omega power 1?
Because when you add like the powers of like 9 plus 1, you get 10, sir.
Correct. 9 plus 1, I get 10. And why specifically 9? Why can't I do it as 1 omega power 8 into omega square? Why should it be omega power 9 into omega power 1? What is 9? 9 is nothing but multiple of?
A multiple of 3, sir.
Very good. Because now you explain the next step, Jerome.
So 9 will be like multiple of 3. So we'll write minus 32 omega cube raised to the whole cube into omega raised to 1. So since omega 3 is equal to 1, so so it will be equal to minus 32 omega.
Very good. Then
Uh,
last.
we take the two equations and we add them. So minus 32 omega square minus 32 omega. So we take as omega is common, 32 is common, minus 32 omega square plus omega. From the equation 1 plus omega square is equal to 0. We shift 1 to the other side. So it will be omega plus omega square is equal to minus 1. So we replace omega square plus omega with minus 1. So we get 32.
Excellent explanation, Jerome. Guys, this is how everybody can answer when your concentration is 100%. Okay, very good, Jerome. Congratulations. Okay, now who is ready to explain the next sum? Next sum is fairly simple. Okay. Yes, Ranika, explain this one now. Ranika, are you ready?
Yes, I'm ready, sir.
Yeah, you can explain, ma. Come on, go ahead.
Well, as you already know, for omega, the root is minus 1 plus root of 3i by 2. Then we split it as minus 1 by 2 plus root 3i by 2. Then for omega square, we do the same. The root would be minus 1 by 2 minus root 3i by 2. Then we subtract both. Then while subtracting minus 1 by 2 and minus 1 by 2 would get cancelled. Then we would get 2 into 3i by 2.
Root 3i by 2. Root 3i by 2 plus.
Yes, sir. Root 3i by 2. Then 2 and 2 would get cancelled. Then since they have asked omega minus omega square the whole power of 4, and the answer of omega minus omega whole square is root 3i, we raise it to the power 4. And we can also split it as root 3 to the power 4 and I to the power 4. Root 3 to the power 4 would be 9 and I to the power 4 would be 1. And we
Excellent. Very good, Ranika. Guys, superb. So we'll move on now. Congratulations, Ranika and Jerome. You may pick anybody in the call to explain, okay? Okay. Modulus of the given function. What is the easiest way to do it? Come on, who can tell me? It's a very simple sum. So that is 1 plus 3i into 2 minus I divided by 1 plus I. Now we need modulus. One method is what? You can multiply these two. Then you can rationalize. You can multiply and divide by 1 minus I, 1 minus I. You can get a number of the form a plus ib. Then take modulus, correct? Or what is the simplest way? You can, when you have z is equal to z1 into z2 divided by z3, let's say. When you take modulus, it is enough to take modulus separately. Did we see this in the class?
Yes, sir.
Yes, so very simple. How do we do it now? Now this becomes modulus of 1 plus 3i. The next complex number is modulus of 2 minus I. The one below is modulus of 1 plus I. So in general, if I have a plus ib as a complex number, what is the modulus of this complex number? Yes, Zain, tell me.
A root of 1 square plus 3 square.
Very good, ma. Very good. See here. Now tell me for a plus ib in general.
Root of a square plus b square.
Very good. Correct. Okay. Now, so this will be nothing but root of 1 square plus 3 square. Very good. Next one will be root of 2 square plus minus 1 whole square, which will be anyways squared, right? So the negative sign doesn't matter. Denominator will be root of 1 square plus 1 square. That's it. So what is this, guys? 9 plus 1, 10, root 10 into 4 plus 1, 5, root 5 divided by root 2, right? So how can I write root 10, root 5 into root 2? So what gets cancelled? Root 2 gets cancelled, root 5 into root 5. What is root 5 into root 5? Come on.
5, sir.
5, that's it. So answer is 5. Is it clear, everybody?
Yes, sir.
Yes. We'll move on. Very, very simple, straightforward. Okay, if x is equal to cos theta plus I sin theta, then what is x cube minus 1 by x cube? See, in our class when we met, right, we had discussed if I have x is equal to cos theta plus I sin theta, I can write it in one more form. What is that? Euler's form. So cos theta plus I sin theta can be written as e power I theta. Do you remember?
Yes, sir.
Yes. Now, what will be x cube? If x is e power I theta, then what is x cube? Correct? This also we had discussed. If x is e power I theta, then x cube can be written as e power I theta the whole cube. Correct? Yes or no?
Yes, sir.
Yeah. Now, so what is this? This is e power I into 3 theta. What is e power I theta? Cos theta plus I sin theta. So what will be e power I 3 theta? Wherever theta is there, now you should substitute. What is e power I theta? Come on, tell me. What is e power I theta? Cos theta plus I sin theta. Correct? What will be e power I 3 theta? In place of theta, I am having 3 theta now. So what you should do? Come on, ma. If I have theta here, I will substitute theta here. If I have 3 theta here, what I should substitute? What I should substitute? Tell me.
3 theta.
Right. That's what I'm asking. Good, Hemant. Okay. So e power I 3 theta is cos 3 theta plus I sin 3 theta, which is nothing but what? Which is nothing but what? Come on, tell me, ma. What is it? X cube. Clear? Now tell me what is 1 by x cube. How can I write 1 by x cube? What is x cube? What is x cube? Come on. E power I 3 theta, correct? X cube is what? It's in front of you guys. Come on, tell me, ma'am. What is x cube? Okay, guys, come on, tell me now. So if I say x is equal to cos theta plus I sin theta, right? I'm sorry. I told you in the class, cos theta plus I sin theta can be written in the Euler's form as what? E to the power I theta. Do you remember?
Yes, sir.
Yes. Okay. Now, what will be x cube? Cos theta plus I sin theta, the whole cube, correct?
Yes, sir.
Yes. Or e power I theta, the whole cube, correct?
Yes, sir.
Yes. Can I write this as e power I 3 theta?
Yes, sir.
No problem, right?
Yes, sir.
Okay. What is e power I theta?
Cos theta plus I sin theta.
Okay. What is e power I alpha?
Cos alpha plus I sin alpha.
What is e power I beta?
Cos beta
Cos
plus
beta plus I sin beta.
Correct. So I am asking you, what is e power I 3 theta?
Cos 3 theta plus I sin 3 theta.
That's all, Sadiq. That's all. That's all. Very good. Very good. So e power I 3 theta is nothing but what? Come on, tell me.
X cube.
That is x cube. Correct. But what is it? Isn't it cos 3 theta plus I sin 3 theta? Yes or no?
Yes, sir.
Sir.
Yeah. So what is the benefit of using Euler's formula? I don't need to do the cube of this, correct? Otherwise, I have to do the cube of this, correct?
Yes, sir.
Using Euler's formula, we understand clearly that cos theta plus I sin theta whole cube becomes cos 3 theta plus I sin 3 theta. Even if you cube it, you will get the same result. All right. So that is the biggest benefit of using Euler's formula. Do you understand the benefit?
Yes, sir.
Okay. What is the benefit, Jerome? Tell me. What did you understand?
Sir, by using Euler's form, you will get the answers directly, sir.
Yeah, cos theta plus I sin 3 theta. Okay, good. Now next step. See here, I am splitting this one sum into two parts. Okay. So now 1 by x cube we are calculating. What is x cube?
1 by cos 3.
That's correct. That's correct. Right now, don't worry about it. You are correct, Jerome. I want you to only connect it with the Euler's form.
E raised to I into 3 theta.
Correct, correct. So it is e raised to I 3 theta, correct. Okay. Now when I bring it to the top, what will it be? E raised to?
minus
3 theta.
Good, Hemant, good, Jerome. So now I keep I here, I take the minus in itself. Is it correct? That's all, nothing, no big deal. Minus I 3 theta, I'm writing it as I into minus 3 theta. Okay?
Yes, sir.
Yeah. So now tell me once again repeat the thing you said. What is e power I theta?
cos theta plus I sin theta.
Yeah, so whatever is there in angle, that becomes the thing, right? So what is e power I? E power I minus 3 theta. What it will be?
Minus cos
No,
3.
don't tell me as it is. Tell me as it is first. Then we will look into minus plus.
Minus
Yeah, come on.
cos 3 theta plus I sin theta.
No. Cos of what? What angle? What sign?
Minus 3 theta.
Yeah. Is this clear?
Yes, sir.
Yeah. Now, what is cos of minus 3 theta? Cos function is even function or odd function?
Even functions.
Yes. So cos of minus 3 theta will be?
Cos 3 theta.
Yes. Very good. What about sine function? Sine of minus 3 theta will be?
Odd function.
So you will get?
Minus I sin 3 theta.
Excellent. Okay. So that's all. So we got the equations that we needed. So the first part, x cube is equal to cos 3 theta plus I sin 3 theta. 1 by x cube is equal to what? What is x cube? Come on, tell me. What is x cube?
E to the power I is 3 theta.
Correct. Don't tell me about e now. Tell me in terms of cos and sine.
Cos theta plus I
Cos
sin
theta plus I sin 3 theta.
Yeah, cos 3 theta. Tell me clearly, Sadiq, once more.
So cos 3 theta plus I sin 3 theta.
Perfect. Okay, now tell me the other one. What is 1 by x cube?
Be cos minus 3 theta plus
That is over, ma. We converted, right? Last step. Tell me last step.
cos 3 theta minus I sin 3 theta.
You're almost ready to get the answer now. So you should only tell me the last part. Okay. Now what are we asked to find? What are we supposed to find?
x cube minus 1 by x cube.
Yes. So I'm subtracting these two. When I subtract, what will cancel? What will get added up?
Cos 3 theta will get cancelled, sir.
Very good. Cos 3 theta will get cancelled. What will get added up?
I sin 3 theta. So it will be 2I sin 3 theta.
That's all. So which is the right answer?
Option C.
Option C. That's all. Are you clear, guys?
Yes, sir.
Yes, sir.
Take it down.
So 1 by x cube.
Yes.
From sir, what's that name? I forgot.
Euler's formula, you can say, or Euler's.
Euler's.
Yes.
From Euler's formula, we can find x cube, which is cos theta plus I sin theta, the whole cube. We can write it directly as cos 3 theta plus I sin 3 theta. Then we split the sum into two parts, sir, and 1 by x cube will be 1 by e to the power 1 by e to the power I 3 theta, which is 1 by e to the power minus I 3 theta, and we get cos of minus 3 theta plus I sin of minus 3 theta, which is equal to cos of 3 theta minus I sin 3 theta.
Why is it
And
so?
then,
Can you tell me about the cos function and sine function?
sir, cos of minus theta will be cos theta, and sine of minus theta will be minus sine theta.
Very good.
And then we solve the thing.
We just subtract the two, right?
Yes, sir.
When we subtract, what gets cancelled?
Cos and cos will get cancelled, and sine will get added up.
Yeah, so I sine 3 theta will get added up. So 2I sine 3 theta. Clear, guys?
Yes, sir.
Good, good. Okay. We'll move on. We'll go into the last sum in this worksheet in math. Then we'll discuss a few physics questions and conclude today's session. Okay. How can I write cos theta plus I sin theta in Euler's form?
E raised to I is theta.
Very good. So now tell me, I'm going to split this sum into two parts. One is the numerator. How can I write cos 4 theta plus I sin 4 theta?
EI for theta.
Very good, Zain. Now, I have a power 5 also here. So, what is this going to be equal to? E power I? Come on.
20 theta.
20
Very
theta.
good. 20 theta. Superb. Okay, guys. Numerator done. Now, let's look at denominator now. Cos 2 theta minus I sin 2 theta. Can I write it as cos of minus 2 theta plus I sin minus 2 theta?
Yes, sir.
Yes. But what is this? How can I write this? In terms of in Euler's form, how do I write it?
E to the power I minus 2 theta.
Very good. Very good, Hemant. Okay. What is the power now?
4, sir.
4.
4. So what is it going to become now?
E raised to minus 8 theta.
E raised to I into?
Minus 8 theta.
Very good. Now let me do the substitution. So what will this be, guys? Numerator is nothing but e power I.
20 theta.
What will be the denominator?
E to the power I minus 8 theta.
Very good. Now what I can do?
Reciprocal.
So e power I 20 theta is there. This one, if it comes to the top, what will happen to it?
E raised to I 8 theta.
Very good. Now, if powers are like this, what can you do to the powers?
Add, sir.
Add them. So what do you get?
E to the power I 28 theta.
Very good. So how can you write e power I 28 theta in terms of cos and sine?
Cos 28 theta
28.
plus I sin 28 theta.
Very good, Hemant. Cos 28 theta plus I sine 28 theta. I already told you cos theta plus I sine theta can be written in the short form as cis theta. So how can I write cos 28 theta plus I sine 28 theta?
This 28 theta.
It's 28
That's
theta.
how cis 28 theta. So which option is correct?
First option.
That's all. Clear, simple. Take it down. All right. Now, a block of mass m is placed on a smooth wedge of inclination theta. So we have a wedge. Or you can consider as a large wooden block, which the angle of inclination is theta. Now a mass is placed over it. And how is the surface? Surface is smooth. When you say smooth, what is absent?
Friction, sir.
Yes, of course, friction is absent. Now, can somebody tell me what are all the forces acting on this mass, students?
Gravitation.
Yeah, Zain, tell me.
Gravitational force.
Yes, gravitational force
Normal
acting on this
force.
mass, which will be perpendicular to, will be vertically down. Yes, very good.
Normal force.
Very good. Normal force. Normal force will be in which direction?
Perpendicular to the mass, sir.
Perpendicular to the surface of contact. So here this is
Surface,
the surface, correct? So normal force will be perpendicular to this surface. Very good. Okay. Now, I can resolve mg into two components, correct? So if you see, this angle is 90. If this is theta, what this angle would be?
mg cos theta.
Wait. Hemant, tell me this angle.
90 minus theta.
Very good. 90 minus theta. If I draw a line like this, then what will be this angle?
Theta.
Theta, because this total angle must be equal to what?
90.
90, correct? 90 minus theta plus theta will be equal to 90. So all that I tried to establish was that when I draw a component of mg here, what will be this angle? Theta. Now tell me, Hemant, what is this component? Or anybody, what is this component?
Mg cos theta.
Very good. How do you say that, Jerome? Why is it mg cos theta?
Because the angle is actually acting on the surface, so it makes the object to slide, sir.
No, that's different. So point is the vector which is touching the angle theta is cos.
Yes, sir.
Right. Now, what is the other component? One
mg
component is
sin
perpendicular
theta.
to the plane, the other is parallel to the plane. Yes, Ritvik. What is this component?
Mg cos theta.
No, mg cos theta is already
mg sin theta.
Yes, this you must be ready, okay? This we must have done several times, but I want you to be thorough with this, okay? The moment I draw the inclined plane and the mass, you should know which is mg cos theta, which is mg sin theta. Clear? Okay. Normally, if we simply place this block, what will happen to this block? Tell me. If I place the block on the wedge and leave it as it is, what will happen?
Slide down.
It will slide down, no doubt about it, because there is no friction. At least friction is there, then it will oppose it, correct? Good, Sadiq. So it will slide down, correct? But now what I am doing is, I am exerting a force on the wedge. Okay? I am exerting a force on the wedge. I am pushing the wedge, okay? So now, what will happen Tell me. The wedge along with the mass, everything is moving towards the left. With what acceleration? A. F is equal to ma. Clear, guys? So the wedge is moving with an acceleration A. Okay. Now tell me, Ma. Now the wedge is moving with an acceleration A. This mass is not sliding down. Correct?
Yes, sir.
This mass is not sliding down. First of all, this frame of reference here is wedge. Tell me whether it is a non-accelerating frame of reference or accelerating frame of reference. Do you remember we discussed? Accelerating frame of reference and non-accelerating, or inertial and non-inertial. This wedge is accelerating or non-accelerating?
Accelerating, sir.
Correct. It has an acceleration. Therefore, it is non-inertial frame. So the frame of reference is non-inertial frame of reference.
Sir, can you explain this again, sir?
Yes, Evelyn. So here you have a wedge, right? This is the wedge. And the mass is on the wedge. If there is no acceleration, right, Evelyn?
Yes, sir.
What do you expect? And the surface is smooth. What do you expect?
The body to slide down.
The mass to slide down. But if you provide enough acceleration and move it, right, then the mass can be stationary. It is given here, the whole system is accelerated horizontally so that the block does not slip. Clear, Evelyn?
Yes, sir.
Yeah, so it's given. So the point is the entire wedge and the block system is moving with an acceleration E. Is it clear up to this point?
Yes, sir.
Now, when I have to apply Newton's laws, should I consider it as an inertial frame or non-inertial frame? Non-inertial frame means any frame which is accelerating is called non-inertial frame of reference. For example, a lift is moving up or is moving down, and you want to write Newton's equation for an object hanging inside the lift or probably a person standing on the lift, correct?
Yes, sir.
Then is the frame of reference considered to be accelerating or non-accelerating?
Accelerating.
It is accelerating, right? It is a non-inertial frame, or you can call it as accelerating frame of reference. So what will happen is if you simply apply Newton's laws, they will fail, correct?
Yes, sir.
So what correction you need to apply?
Pseudo force.
Yes, you need to assume a pseudo force to be there. In which direction?
Opposite direction.
Opposite to the direction of the acceleration of the accelerating frame, correct? So
Yes, sir.
acceleration is in which direction in this case?
Downward.
No.
I mean along the wedge.
No. Negative x-axis.
Okay, sir.
Yes. So I should consider the pseudo force on the mass small m to be in which direction?
Positive x-axis.
Positive x-axis. Exactly. So I will be able to solve the sum only if I assume a pseudo force acting on the small mass. Understood?
Yes, sir. Understood.
And what will be this force equal to? This pseudo force will be equal to mass into the acceleration of the entire wedge, correct?
Yes, sir.
That's the definition, right? Pseudo force is nothing but mass into acceleration of the frame of reference. Is it clear?
Yes, sir.
Yes. Now now the solving starts. If I don't consider this and then solve it, we will certainly be wrong, correct? Why? Because we are applying Newton's laws in a place where we cannot apply. Is that making sense?
Yes, sir.
Yes. Now, tell me. I'm going to resolve this f into two components. One is parallel to the plane. Maybe I'll use a different color. Okay. So can you tell me what is this angle? Anybody? Are these two corresponding angles? Yes, no?
Yes, sir.
So what will be this angle?
Theta, sir.
Right. So what will be this component and what will be the vertical component? For this f. Because this is theta, what is this component? This is the force. So what is this component? Come on, tell me. Very, very simple. I am drawing it separately here so that you're not being cluttered. Okay. Say f is equal to ma is acting here. I am resolving it into two components. One is along the plane, another is perpendicular to the plane. And we have established that this angle is theta. Now tell me, what is this component along the plane? What is this? What is this? What is this? Tell me. Yeah, Hemant is messaging me of cos theta. Why are others not telling that? So what is this, ma? Very simple.
Sir, is it MA cos theta?
Yeah, of course, ma cos theta. What else? Very good, Prathvik. What is this component?
MA sin theta.
That's all. There is no struggle at all. Okay. So this is ma cos theta. And what is this? Ma sin theta. Now everything is clear for us. Everything is ready with us. Okay. So now, tell me all the components acting along the plane. Come on, tell me, guys. Let's say this is the mass m. What is the component along this side? And what is the component down?
mg sin theta, mg cos theta.
Mg
Sin
sin theta. And what is this?
MA cos theta.
Ah, very good. Correct? Understood?
Yes, sir.
Yes. Now, once again, I'm just drawing it so that x and y I'm drawing it separately, okay? So that you are clear. So this is your mass. What is acting in the vertical direction?
Normal reaction force.
Normal reaction, okay? And what are acting in the downward direction?
Gravity.
One is mg. Is there anything else acting downwards?
Yes, sir.
Mg, not mg. What is acting?
MG cos theta.
Mg cos theta. Very good. What else is acting?
MA sin theta.
That's all. So we also have is it clear, students? For the black block to be
Yes, sir.
in equilibrium. Yes. So this block is in equilibrium. It is given in the question that the block does not slip on the wedge, which means the block is not moving. Okay. Block is not moving means all the forces are cancelling each other. Correct or not? So the ones which are parallel to the plane are cancelling each other. The ones which are perpendicular to the plane are cancelling each other. Correct. So what is balancing? What is balancing your mg sin theta? What is balancing your mg sin theta?
MA cos theta.
MA cos theta. So can I equate mg sin theta to MA cos theta? Yes or no?
Yes, sir.
Yes. Okay. What else can I equate? There is no movement in the vertical direction, correct? It's not moving in the vertical direction, which means the vertical components are also cancelling each other, balancing each other, the ones which are perpendicular to the plane. So what should I equate? Come on, everything is in front of you.
Normal reaction force.
Yes, normal reaction should be equated to what?
MG cos.
That's all, Hrithwik.
Yes, sir. Sir, MA sin theta
So what I should do?
plus MA sin.
Yes. Now all the equations that we require for solving the sum is ready with us. Now we'll see what is the question. The force exerted by the wedge on the block is the force exerted by the wedge on the block. What is being asked? Tell me. What is the force exerted by the wedge on the mass?
Normal reaction force.
Very good, Jerome. Congratulations. So we are asked to find the normal reaction. That's it. So we need to find normal reaction. That's all. But there is no A in that, right? So we must substitute for A. Can you tell me what is A from this? What is A?
Cos theta, sir.
Mg sin theta is equal to what?
MA cos theta.
So what gets cancelled?
M.
So what is A? Bring this cos theta down. So what do you get?
G tan theta.
G tan theta is correct, Sadiq. Or I will simply write as G sin theta by cos theta. Okay.
Yes, sir.
So wherever A is there, I'm going to substitute what?
G sin theta by cos theta.
Yes. Into what?
Sin theta.
Very good. So I have mg cos theta plus mg into, what is this? Come on, sin theta into sin theta.
Sin square theta.
Yes. Now take LCM. What is LCM?
Cos theta.
Yeah. So when you multiply cos theta here, what you will get?
Cos square theta.
Yeah, mg into cos square theta. Plus already you have what?
Mg sin square theta.
Very good. Divided by
Cos theta.
Cos theta.
what can I take out common?
Mg, sir.
Mj can take out common. So what will I get inside?
Cos square theta plus sin square theta.
Very good. What is cos square theta plus sin square theta? Cos square theta plus sin square theta.
1.
1, right? Should I only say sin square plus cos square? Good. So I get mg by cos theta. Clear, guys?
Yes, sir.
Which option is correct?
D option.
D.
Did you understand? I will capture the recording and send it to you. Listen to this recording once more. Okay, students?
Yes, sir.
Yes, sir.
Sure. Okay. So all the best. We will, of course, we had to overshoot. Okay. But it's a very interesting, important sum. Okay. So that you will get a clarity on pseudo force, which is very, very important. Right. And in the next similar session, we will discuss few questions on friction. Next few questions are on friction, in-depth questions, right? So we will discuss them so that your concepts are very clear, right? And I'll also give you a few more questions to solve during the period, as part of our daily practice problems. Try them, okay? And soon we will also have some sessions for doubt clarification, okay? And at the same time, you can also connect with me, ad hoc, right? You got a doubt, you want to discuss, you need not wait for a doubt clarification session for clarifying the doubts. You can clarify then and there. All right. Okay, students. So keep it up. Keep your daily practice problems going. That will help you reach great heights. Trust me. Okay, students. All the best for being here on the call. Take care. We will meet again on Monday. So tomorrow we are going to have an online class, 6 to 8. The class will be there. I want you to revise, go through whatever notes you have taken down, right? When Yogesh sir has taught rotational motion and gravitation, he'll be reviewing it again tomorrow, and he may add up a few numericals and questions. But prime idea is to review the topic, because especially rotational motion is a topic which requires 2 to 3 revisits. All right. So tomorrow, sir will be discussing that part online for you guys, 6 to 8, which will again be recorded, and that also needs to be listened to twice or thrice, right? Because rotational motion is one of the most important chapters, and I will also be taking up a lot of questions in the weeks to come. Okay. And as we discuss them, the concepts will get stronger, and you'll be able to solve different types of questions from the topics as your understanding goes to the next level. Okay. All the best, students. Take care. Good night.
Thank you,
Thank you.
sir. Bye,
Thank
sir.
you, sir.
Nice, students. Bye. Take care.
Ban, thank you, sir.
Bye, ma. Bye, ma. Take care.
Thank you,
Bye,
sir.
sir.
Bye, Ranika.